recording going. So we're going to clear out, close all elements that are currently open. And now I would like to go and undertake some steps to build this model. Okay? So I'd like to do File, New, Model, and this will be called Hierarchical Infection Model. Yes. Oh.
And unfortunately, I can't spell hierarchical.
Okay. Thank you, greatly for highlighting this. Give me a second while this gets connected, and here we go. Okay. Here we are. Okay, and there we go. Boom. Okay.
It hasn't quite boomed.
Okay. There we go. There's an echo. It takes time for the echo. Okay, ladies and gentlemen, hierarchical infection model. I'm going to place it as I am want in a location which I can share with you. Okay. Boot camps, and this is Sydney. And the model's time units, ladies and gentlemen, will be years. Year. Okay? Remember, those time units provide a yardstick to measure time. What does 2 mean? Is it 2 days, 2 months, 2 years, what have you? Okay. Good. Okay, now, having done that, we're going to add a class. Okay? We're going to give this model some class.
Was that years or?
Years. Yeah. Okay. So we're going to add this in. We're going to do new agent type, and the agent type will be city. Okay. Is it capitalized or not? Yes. Capitalized. Okay. So it's going to be capitalized because it's sort of a cityhood, cityness, and there's going to be many particular cities that are different particular instances of city. Okay, and now, ladies and gentlemen, we're going to go to the palette and we're going to drag a rectangle such that it lies astride the origin. Now, you may wonder what this origin means. You may wonder about why I always place things. If you place things on the origin, ladies and gentlemen, the visual location that you see for them will be the same as their logical location. So the fact that they're placed here, right on the origin, is going to be an indication that visually they're going to be bang on their logical location. If we, by contrast, place this to the right of the origin, their visual location would be to the right of their actual location, their logical location. Okay? So the fact that we're putting this on the origin means we can have a one-to-one correspondence between, on the one hand, their apparent location and their actual logical location, which is sometimes useful. Often it's not a big deal, but at the least you got to be consistent about it for different things you're putting on. So their difference between the relative position of two things is the same as the distance between their logical position. Okay, so we put it there. Okay, ladies and gentlemen, we are going to set it, and to do this, we're going to go down, Joe, we're going to go down into the rectangle properties to where it says width and height, and we are going to set it to be 100 and 100, okay? And we are going to put its position and size here. Do you see it says position and size in this area too? For its x location, we're going to put 0. And its y location, we shall also put 0. Kurt, is there a loose cord over there?
Yep.
Could you bring that to me? It's a USB cord. Thank you, Kurt. I need it for my thing, else it's going to go under too. Okay, thank you. Okay, so ladies and gentlemen, we put 0, 0, so it's, excuse me. Oh my gosh. We don't want that. We want it centered on the origin. I'm sorry, it should be minus 50 and 50. And minus 50 and minus 50. Please excuse the misstatement on my part. Okay. Ladies and gentlemen, so it's width and height 100, x and y location minus 50 and minus 50. Okay. Are we okay with that? Okay. So next, ladies and gentlemen, I would like to go to the connections area of cities. And does anyone remember, how are we going to set it so that when we have two things connected, let's say two cities or two people, how do we set it so that we actually see any such connections? Those connections may be there logically, but unless we do something, we won't see them. What do we have to do? Yeah, and where do we do that? Yes, an animation under what? Connections. Connections for the thing to be connected. Not for main, but for the thing to be connected. In this case, we want cities to be connected visibly. So we click on Connections in City, and we go down to Animation, and we will select Draw Line Connecting Agents. And you'll notice we could set the width of this line, and I'm going to set it to be one of these larger values. Okay? 4. Are we okay with that? Okay, ladies and gentlemen. Very good. Okay, next, I am going to go up to main. We're going to go down main, and ladies and gentlemen, we're going to drag city into main and call it cities. This is a population of cities. And what do I need to do to make it a population? Click on population of agents. Okay? And we could hard code this, but I would feel negligent. Instead, we're going to add a parameter that is going to be called count cities. What sort of parameter will it be? An integer indeed. I heard it muttered. And we are going to, by default, have 10 cities. Okay? Great. Okay, ladies and gentlemen. Ladies and gentlemen. Okay. And we are going to now set it. So how do we make that operational? So that actually the number of cities will be as given by count cities. What do we have to do? Under cities, we need to say initial number of agents, count cities. Are we okay with that? Okay, ladies and gentlemen, what I'd like to do now is go and we are going to go to cities, and we are going to lay those cities out at random locations. How do we do that? Yes, initial location. So we're going to lay them out at a uniformly distributed x and y value. Okay? So uniform between 0, and how do I make it up to the height of the width of the space? Can anyone tell me? This dot space width. So we're asking us, give us the space width. Hey, myself, give me the space width. This is going to return a number, and then it will draw a value from a uniform distribution, a continuous uniform distribution between 0 and whatever number this returned. Does that make sense? Okay, now 0 and space height. Okay, a lot of using any logic is these old familiar patterns. Okay, can we run this model? Let's run it. Run early, run often. It'll let you spot errors sooner. It'll have what's called, ladies and gentlemen. Here we go, and we're going to run it. And now my computer is slow. Okay, there we go. So now we have some cities laid out. Now, if we run this many times, you'll notice we get the same results. Why is that? The random seed is the same. How do we change that so that random seed is different between them? We go to simulation randomness under the experiment, and we set it to be random seed. Now if we run it, we're going to see somewhat different city locations, okay? There we go. We'll run it once, we'll run it again. We're going to see different patterns of cities, okay? And I'm going to set it in this experiment, just based on what I see, I'm going to set it so it counts cities of 5 cities, okay? And it won't be quite crowded. We're going to benefit from having them there. Okay, great. Now, ladies and gentlemen, I want these cities to be connected if they lie within a certain distance of each other. Where would I go to set that? Where would I go to set that? Well, where would I go to set how far apart these cities would have to be connected? Indeed, if they're even in such a network. Well, what is it that contains those cities? What is it that contains that population of cities? It's Maine. So we're going to go to Maine, and we're going to scroll down to the space and network area. And we're going to tell it in Maine, in the space and network area of the properties, we are going to tell it to use a network type that's distance-based with a connection range no less of 500, okay? And we're going to run that. And really, I feel, yes, that should have been a parameter, but time is a-fleeting. So here we are, and as we run the model, we'll see different configurations of cities, okay? These cities are connected together if they lie within 500 distance of each other, okay?
Can I see the last step again?
Sure. So we want these cities to be able to be connected together. We've already set it so that the cities, if they are connected, there will be a line connecting them. But we want to set it so they're actually connected. How do we do that? Well, the city population lives within Maine, okay? The city population lives within Maine. So we need to go within Maine, go down to space and networks, the space and networks area of the properties, and we want to set it to be a distance-based network with a connection range of 500.
So which space and network and what?
It's under network type.
I don't have that coming up.
I think under space and network, you look down here under network type. I think I'll change it while we're at it to 300, just to make it a little bit less connected. Connect two cities only if they lie within 300 instead of 500 of each other. So not all cities are connected together. I did it to 300. That seems to work okay. Okay, ladies and gentlemen, so I changed it to 300. Okay? Okay, ladies and gentlemen, next, I would like to, okay, so next I would like to go to city. So we have cities arranged in a network. Now we're going to go to city, and we're going to start building an infrastructure within the city, okay? And what we're going to do here is we're going to add in a parameter to the city called population size. So the city is going to have a population, okay? Are we okay with that? Okay, what sort of parameter will this be? Is it a double precision value? Is it a sex? Is it a person? It's an integer indeed. Now, we're going to draw this integer from a distribution. And that distribution will be a uniform distribution, but it will be a discrete uniform because it's an integer. It won't be a continuous uniform. You don't want 32.395 people. You want to have a discrete number, an integer result. So we're going to type uniform underbar discrete. And you'll notice it gives us some choices. And we're going to choose the second one, min and max. Okay? The minimum will be 300. The maximum, ladies and gentlemen, 100 to 500. So the city populations will be 100 to 500. And guess who will live in that population? It'll be a population of what? Well, of people. So we need to add some people into the model. So let's go add, ladies and gentlemen, a person class. Okay? So we need a theory of personhood. So we're going to right-click on the model, and we're going to say agent, new agent type person. Okay? Are we okay with that? A person. So let's be clear, we're going to have main, and we're going to have cities, and within cities are going to be persons. We could have neighborhoods. We could have households within that. Very readily done in the same basic way we're doing that. But I'm going to show 3 levels. Okay? For time is of the essence. Okay. Ladies and gentlemen, let us go to person, and let us lend this person an appearance. I want to lend them a little picture of a person. You've done this before. So we're going to drag it into person. There we go. And not only are we going to drag it in, ladies and gentlemen, but we're going to make it a smaller scale. Now you can do this by frobbing it, by sort of futzing with it, but I'm going to set it in its position and size so that the scale is 0.5. We can do that by being on the person group, and we can set the scale of that person to be 0.5, okay? So we're going to say 0.5 here for the group as a whole, okay? 0.5 and 0.5. Okay, and we're going to run this thing now, okay? And, oh, wait, sorry, there's no people. Okay, sure. Okay, it's not that interesting. Okay. So how did I do that? I went down to person, to this image of person, and set it to be 0.5, 0.5. Great. Ladies and gentlemen, what would we need to do to actually make those people appear within the city? Create a population of people. So, ladies and gentlemen, how do we create a population of people within the city? Drag in person to the city. This will be called, we could call it city population maybe? Why don't we call it city population? Sure. What do we have to do to make it a real population and not merely a claimant population? What do we need to do? Yeah. So we need to go set it to be a population. You've done this many times now, and that's exactly the point. I'm getting you to rehearse these things. What's the initial number of agents, do you think? Population size, yeah. Population size, great. Okay, ladies and gentlemen, we're doing good. Okay, okay, now, we want to set their initial location within that city, okay? Their initial location. So we're going to set them in the specified point. We're going to have dynamic populations. People will be moving here between cities over time. So we want to have people coming into cities to be displayed at the right location. So for the city population, for the initial location, we want to set their X location to be drawn from a uniform distribution between, now that's the rub. What is it between? Well, let's go up and look in the city. There's this thing called rectangle. Let's go see if we can do it using that. I'm going to say uniform between rectangle. Now, I've never done this before, but I'm feeling adventurous. Get X. Okay, I wish there were a get min X last. Okay. Yeah, sure. Dot get X. That will be good. The X location is minus 50. Okay, so we'll do uniform between that dot get X and then the following. Uniform between that and, in fact, we could do it even more nicely, but it might be confusing to you. Okay, I'll do it. This is what we want. Uniform. We want it to be located. Their x location to be the x location of this rectangle, which is dot get x. Okay. Plus uniform between 0 and rectangle dot get width. Okay. I think that should work okay. I've never done this before, but I'm feeling okay. And this should be between get y and uniform dot rectangle dot get height. Okay, just like that. So let me go put this up on the big screen. This is the x location of the person, and this is the y location. It's just like this. It's mutatis mutandis. It's just changed in its space in a couple details. X is changed to y. Get width is changed to get height. That's for the person's location. So they're going to be placed at the x location plus some distance over. Either if they're all the way over for the width, they'll be over here. If it's 0, they'll be right here. Same thing for the y. They'll be placed here on the y location plus a uniformly drawn value between this and this. Okay? Are we okay with that idea? Okay. Can we run it? Let's go see what happens. There we go. There's our city population. Do you see that? Okay. Okay. Ladies and gentlemen, we can run this, and that's a pretty nice depiction of it. Okay. Now, ladies and gentlemen, we're going to impose a network on the people within the cities. Are we okay with that? Where do you think that network's going to live? Where will we specify that network, the characteristics of it? Where do we specify the network for the cities? In what? Where did we go down and set the space and network? We went to the cities themselves were embedded in Maine. And so we went to Maine and we scrolled down and we set there to be a distance-based network with a connection range of 300. Do you remember that? Okay, so we're going to go this time to city, and we're going to scroll down, and we're going to set there to be a distance-based network. Or we could do a scale-free network. What do you think about a scale-free network? Maybe that would be a nice thing. I think I'll do a distance-based, though, just to keep it nicer. And the distance-based connection range will be 75. 75 for distance-based connection. How are we going to have it so the person actually gets displayed as connected with another person to whom they're logically connected? Where do we go? We want them to be visibly connected to a person to whom they're logically connected. Where do we go? Connections of whom? Cities? Of persons. Not of Maine, not of cities. Persons. So we'll go to connections of person and we'll select draw line connecting agents. Okay? Okay. Okay. Ladies and gentlemen, let's run the model.
Okay, so everyone's really behind. Yeah. What was the distance?
75. 75. Sorry, I'm going to death to finish in time here. And I should go slower. Okay. So ladies and gentlemen, what we just did, I'll just rehearse the last couple steps. What we did is we went to person and we set in their connections. We went down to animation and we chose draw line connecting agents. Okay? And having done that, we then went to the city. Well, or we went to the city first, and we scroll down in the city to where it was a network type of distance-based connections with a connection range of 75 for people, okay? It looked a bit dense to me, so I think I'm gonna abbreviate that to not be 75. Distance 25. I'm sorry, I mistyped. I misread. It's actually 25 we want, not 75. 25. So within city. So main sets the network characteristics of the population within it, namely cities. City sets the network characteristics of the population within it, namely the city population. So we go down in cities to space and networks, and we go set the network type to distance based with a connection range of 25.
Why do you have the connection range option?
Is it set to distance based?
No.
You have to set it to distance based. If you set it to other ones, it changes what options you have for different networks. It's only if you set it to distance based that you have a connection range option. Okay? Okay, let's run this thing. Okay, here we go. You could run it. Boom. There we go. Okay. Now let's zoom in. I'm going to zoom in. Some of you have mice. I am mouseless, despite my admonitions, and I am engaged in fruitless frobbing. Okay, let me just go view, and I will zoom in this way. Okay. Thank you, Jeff. He doesn't want to see me fruitlessly frob. Okay.
There want them to see you fruitlessly.
Yeah. Okay. Thanks. So you could do a mouse wheel in, or you can do view. You could choose from here view, and then that will let you zoom in here. Okay. I think it looks a bit dense. Because of that, we're going to go down to person, and we're going to set the line width. I wonder if we could set this to 0.25 points. I don't know if we can do that. I'm not sure.
Choose a different color, lighter color.
A lighter color to connect people,
Yeah.
like medium orchid.
It is a light orchid.
Yeah.
Wait, how about this? Look at that. That's pretty sweet, I think.
Yeah.
Okay, ladies and gentlemen, go to person, go to connections, and go down to the line width and make it, instead of 1 in connections in that animation area, instead of 1, make it 0.25. Can you try that? And I think you'll be pleasantly surprised, even without medium orchid. Okay, there you go. There you go, folks. It shows some structure without being overwhelming, I think.
Yeah.
Now, if you want to use your mouse wheel, oh, thank you. I thought I plugged it. Okay. It's late in the day, Jeff. Okay, here we go. Hey, oh my gosh. Okay, there it is. Okay, we might want to set it even.
How do you increase the size? Use control.
Use control and mouse wheel.
You
Yeah.
can pinch and zoom too on your Mac really well.
And you know, it looks even a bit dense there, so I'm going to lower the maximum connection size from 25 a little bit further. I'm going to lower it to, this is in city, I'm going to lower it to 15. Yeah, good. 15. Okay? So I just went to see, I went down and it changed the connection range to be 15.
Are you in person?
I'm in city. I've selected city. Yeah, it's a bit confusing because I've selected it over here, but it's showing person here. It's in city that I'm located.
Oh, okay, sorry.
Yeah. Okay. If you select things over here, it can be confusing because it looks like it's selected there. Okay. Okay. So I'm going to run it here. Okay. Here we go. And there we go. Okay. So now we have a somewhat nicer, less dense, less horribly dense network. Okay, ladies and gentlemen, So, what I'm going to do now is we're going to add a parameter into main called migration rate. Okay? Into main, we'll have a parameter and it's going to be called migration rate. Okay? Migration rate. And what do you think type of parameter will it be?
Right.
It'll be a rate parameter. Good. And it will be set, ladies and gentlemen, to 1. It'll be set to a per year rate. Okay. Of 1.0 divided by 10.0. Okay? Okay. Okay. Now, we're going to actually have people move between cities. Okay? Great. So here we're going to go, and we're going to go to person. Who needs a bit of help? TA help. TA? Okay. We're going pretty well here, folks. Okay, ready? Okay. Within person, I would like to go add an event. And it's going to be called migration event. Migration event. Okay? And the rate, this is going to be a rate. What sort of trigger type will this be? Will it be a timeout, a rate, or a condition?
Right.
Be a rate. And the rate will be what? It'll be given by that parameter. So we're going to say main dot. It lives in main. It's mains. Main dot migration rate. There we are. Main dot migration rate. Now, the job of an event is mostly to do something. When it fires, we do something. So again, this is a rate event, and with a rate being given by the migration rate. Ladies and gentlemen, we're going to now do something here, okay? Sorry? Okay? Okay, ladies and gentlemen, we're going to now type a bit of code here, okay? Okay, so this is what we're going to do. We are going to first pick a city that to which we're going to go. So we're going to say city, C-I-T-Y, capital C, city, destination city. We're going to give a nice little name to our destination city. And it's going to be city. We're going to get a randomly connected agent for our city. So we're going to ask our city, hey, get a random connected agent. Okay? Now, I personally don't like having to do this thing to say, hey, this is really a city. I don't like it at all. And Kurt showed you one way to do that turns it into a city. I'm going to show you a different way to avoid it. If you go to city and you go to connections, in connections, you'll notice that you can say agent type here, and you can choose city, okay? Okay. So we're going to change these connections so that it knows that it's in city. Okay, now.
Can you show the migration event logic one more time?
Sure, but I'm not done with it yet.
Okay.
I'm going back to it.
Okay.
So here's for the migration event. we're going to do city, and I'm going to do city.connections dot, and this is going to be get random connected agent. That's what I want. That's what it is. Okay, just like, hey, oh, come on, do autocomplete for me. Get random connected agent. Oh, man. Sorry, I just want to make sure it's returning the right thing. Let me just make sure it's returning a city before I lead you down a primrose path. Yes, it's fine. So we've eliminated the cast. So now we have to say city.connections.getRandomConnectedAgent. And that's because we changed in our connections so that it was, the agent type was city. So we're,
Nate,
yes?
Just ask a question. Can you go back to the code bit?
This right here?
Yeah, so city there is referring, can that refer to any particular?
My city. So it turns out if you look up within a person, there's a thing called city here in Maine, and those indicate the city in which I am nested and the Maine in which I am nested.
Okay.
So by virtue of the fact that a person could be in a city, we have this thing around that's called city, that's my city. Now that isn't the only way we can get it. We can also ask this dot get city, and that used to be the way that we would do it. But any logic provided starting in 7, this ability to just use that variable there.
Okay, and so just for my own clarity's sake, if there was a different object, say region or whatever, that you weren't in, you wouldn't be able to, that wouldn't appear.
That's, so to be honest, I'm not 100% clear about how exactly it figures out, but somehow it knows that, okay, because a person's embedded in a city and a city is embedded in Maine, that it needs to construct those 2 layers. If there were another thing entirely, like, I don't know, a school or something like that, and the agents weren't somehow in schools or something, then there wouldn't be a choice for that. Yeah.
Thanks.
Okay.
You said there was something you had to change because I've tried to compile and I've written the error.
Yeah.
Like mismatch cannot.
Exactly. So you needed to go to, in city, to the connections, and you need to make sure that the connections say agent type city. If you didn't do that, it'll just say agent, and it won't know that cities are connected with cities. It may think, well, a city could be connected with a person, or a city could be connected with a moose or something.
So do you do that in person as well and make the agent type person and then go and make
Yes.
the agent type?
Yeah, you can. In person, you can say the agent type is person, in which case you won't have to engage in saying, hey, look, this is an agent, but they're really a person, trust me. That's what that cast thing is. That's what that thing in parentheses is. And Kurt showed you how you could live with casts, but I showed a way that you can avoid casts. Okay? Prevention is the best dose of medicine. Best type of medicine. Okay? Okay. I can say that having lived with a cast for a while. Okay. Ladies and gentlemen. Okay. So we're going to get, this is our destination city. And what we're going to do is, if the destination city is, if we have one, if we indeed can get to a city, we're going to go to it. Maybe this city has numbers in case this will not be found. So we're going to say if destination city is not equal to null, if we have a destination city, in short, if it's not nothing, null is how it would say, I don't have any destination. I couldn't find a neighbor. In that case, we're going to go to that population. And we'll say this dot go to population. That's me. I'm going to go to this population, destination city dot population. Okay? And we're most of the way done. Okay. We're most of the way done. But one ugly fact remains. Well, let's go see it. You got to see it to appreciate the need for it. Okay? So if destination not equal to null, go to the population. Now you noticed I had put curly brackets around this originally, but then I decided to strip them out because I want to see you have both forms. This is another way people would present it. So let me put this up. Oh, it says it's not, it couldn't. Okay, so what did I call it? City population is what I called it, right? Let's go see what auto completes to. I think it's called city population, so I should have called it city population. Okay? Okay, so if there's a destination city, I'm going to move to that other population. Can we try this now? Can we try it? Okay, let's run it. Run. Let's go look at each of those cities. Watch this, folks. Let's go look at this navigation menu. Look at that. Within the navigation, we could get down to particular cities. And then within each city, we're going to have populations. This is 190 people in it. City 2 has 373. City 2 has, the third city has 215. But if we go look at this, where are all those people located? In the very heart of the city. So we need to put them into a nice place. We need to put them in their place, okay? So we need to have a distribution. And I'm sorry to tell you that, but we're going to put them to be in a randomly located spot. Okay, ladies and gentlemen. Ladies and gentlemen. Now, there's a good way to do it, and there's a less good way to do it. Time is of the essence, and so I'm going to ask you to do something I almost never ask my students to do. Oh, man. Oh, man. Okay. Yeah, the good, the bad, and the ugly. Okay. Oh, man. Okay, sorry, I'm having a civil war in my head. I will not do it. I will not stoop to that. Okay, I'm going to do it right. We're going to do it right, okay? We're going to do this thing right. Okay, we're going to go city. Okay, watch this. This is going to be a thing of beauty to do it right. Okay? And even if you're late getting out of here, you'll be beautifully late. Well, no, I'll try not to get you late out of here. Okay. So we're going to go up to city. And ladies and gentlemen, there's something that's been gnawing at me because we already located these people at random positions here. Do you remember this? We wrote this, not 15 minutes hence. Do you remember that? Okay. So I don't want to go repeat this, especially because the rectangle is going to live in city. I'm not going to do this. So what I'm going to create, humor me for this, okay? I'm going to create two functions. One will be called get random x location, and it's going to return a value. And another is going to be called get random y location. And if you want, using the Krugerian trick, you can click on that, hold down Control and let go, and you can copy it and do get random y location. The key is that they should both return a value. Okay? Are we okay with that? We're about halfway done now with securing beauty. Isn't that a pretty good trade-off? Okay, you seem unconvinced. Okay, well that's fine. Okay, so ladies and gentlemen, let's go down to city population, and we're going to copy the code from here, and we're going to copy it up to get random x location. Okay? There we are. That was the code that used to live. It used to live associated with this. Now I've copied it up instead to this function. Same thing with this code. then I won't have to go repeat that every time and twist it, bend it to my will. Okay, ladies and gentlemen, so all I did is I took the code from here and I put this one in get random X location and I said return that value. And I put this one here in get random Y location and I said return that value. Now you may wonder at my madness, but perhaps you were wondering about that long ago. So what we will do here, instead of having this long expression, we'll say this dot get, can you fill it out for me? Random X location. And then we will call here this dot get random Y location. Okay. Okay, I feel like the fourth movement of the Ninth Symphony.
This only works with cities that are the same size.
That what?
Are the same size.
Nope, 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 nope. Each city is going to know how to pick its random location, and it does so from getX and the width. You could, in fact, have those differ between cities. Okay, so ladies and gentlemen, we have two functions. Within each function, we're going to return the corresponding snippet of the value computed by the corresponding snippet of code. This used to live, that code used to live here, but I took it out and I put it here and I put this one over here, I returned them, and now I just call them to return them. Now, who needs TA help? I'm sure there must be people dreadfully lost. Okay, either no one needs help or they're beyond help. Okay. Okay, and the minutes are ticking down. Okay, I promised to get you out, and I'm going to observe that promise. So we're going to go back to migration event now, and watch this. Watch this. The problem is, ladies and gentlemen, nobody, as John Sturman and Nelson Repenning wrote once in an article, no one ever gets credit for putting out fires that never happen. And I've just avoided you having to worry about a fire, but you're not going to appreciate it. Because, I mean, I appreciate the beauty in my heart, but to you it will not be obvious. Okay, okay, ladies and gentlemen, so now after we say go to population, we're going to say this dot set xy, and we're going to say destination city. Oh, it's so beautiful. Destination city get random X location, and destination city dot get random Y location. Okay? Okay. There we go. Okay? And believe me, this would have been filled with hideous things had I not done that. Okay? It would have been filled with things that would have left you shaken from here. And now, ladies and gentlemen, we're going to run this, but we're going to see one more dysfunction that we're going to fix within the next 5 minutes. Okay, who needs TA help? The TAs sit underutilized. Okay, the TAs are ready for deployment. One final deployment. Okay, let's run this model. Let's build the model and let's run it. Run. Here we go. It's pretty nice. People are moving into these new cities, but the networks don't seem to be forming around them in quite a natural way. Well, actually, it's not too bad. Sorry?
I didn't have any movement.
Okay. Kurt, could you help secure movement? Okay.
They look more like ants now than before.
Okay. They're moving now between cities, ladies and gentlemen. Now, what I would have thought was necessary, but seems to have been avoided, is for it to actually recalculate the networks. So I'm going to say destination city dot apply network here. Apply network. Okay? And now it will actually apply a network so that they're knitted into the network. It didn't seem to be needed, which surprised me, but I've seen stranger things. Okay? Okay, Alan, could you help Tom here?
Yeah, I think it's in the migration.
Okay, here we go. So ladies and gentlemen, now we have people moving into and out of cities here. So these three cities are moving back and forth. People come in, they're knitted into the network, and then they leave.
So what was the purpose of the apply network that you just added?
So basically that's to properly knit them into the network so that they are properly integrated, connected with people nearby them in their new location. And my experience has been that without doing that, it won't necessarily create, it won't properly place them in the network. And so we basically tell it, hey, apply this network for their new population so that it will connect all the people who live within 15 units of each other. Okay? Okay, so that's pretty good, ladies and gentlemen. That's pretty good. Okay. I think that's all we'll leave it for right now. We have people moving between cities. Tomorrow, we're going to complete the arc by having people spread infection. And they'll bring infection from one city to another. Okay? They'll bring infection from one domain to another. But for now, I will let you go in time as I have promised. And you will go having seen beauty, but not fully grasped it, potentially. So here, ladies and gentlemen, we're setting their location to be a random X location, a random Y location, and that has replaced hideous code that you would not want to look at. Okay, so that's tomorrow morning. We will open after a retrospective with turning this into an infection spread model where people will bring infection from one city to another, much as sparks bring fire from one area of the forest to another. And they'll spread that fire. Okay? So that's all for today. Thank you for your patience. And let's once more give Kurt a hand for his good performance. Okay, so see you tomorrow morning. I would like to ask the pardon of the group if we could start tomorrow at 8:30. It would help. I woke up at 2:30 this morning, and I'd like to catch up on a little bit of sleep. Thank you very much. Would you like me to show?